During the Middle Cambrian, the Circum-Adirondack area was occupying the southern margin of Laurentia, a paleocontinent primarily made up of present-day North America and Greenland, which was rotated at about 90 degrees from its present orientation. Given its paleolatitude at 30 degrees south, this area was likely influenced by subtropical highs, resulting in generally sunny skies and dry weather. The latter, coupled with lack of land plants and soil development, resulted in a very limited subaerial weathering. Given the compositional maturity of the Potsdam Sandstone, the sand grains that originated from the Adirondack, Superior, and Grenville provinces must have spent a considerable amount of time being reworked and slowly weathered.
Potsdam Sandstone was defined by Emmons as the sandstone that unconformably overlies Proterozoic basement in the area surrounding the Adirondack Mountains. Here at Hanover Falls, Potsdam Sandstone is represented by a suite of Eolian dune and aquatic deposit made up of well-sorted and hematite-coated quartz grains.
The sandstone is made up of fine to medium-grained, well-sorted and well-rounded monocrystalline quartz sand grains coated with hematite and cemented with optically continuous silica. Sand grains form 1 to 10 mm thick laminae reflecting variations in grain sizes. Inverse grading is locally found in thicker laminae. The very hard, compact, and weather-resistant qualities, coupled with its vivid reddish color, made the Potsdam Sandstone a very popular architectural stone since the 1850s. Just some 10 miles from here, St. Lawrence University campus hosts one of the many fine examples, a historic herring coal hall. The rock here is a fine to medium-grained, well-rounded, well-sorted, laminated, plain-bedded, or cross-stratified, hematitic, silica-cemented quartz arenite. It has very unique decorative properties because quartz grains were individually coated by hematite before the silica cement was introduced. For that reason, the reddish hues resist well to the superficial weathering, making the stone ideal for decorative facades. These Potsdam outcrops consist of large, dune-scale cross beds in thick sets that range from 2 to about 20 meters. Cross beds are erosionally truncated at their tops and are laterally continuous. They can be followed for about 100 meters perpendicular to and 200 meters parallel to the direction of the dip. All truncation surfaces likely formed as a result of wind erosion, and they range in dip from 0 to 30 degrees. Individual beds within a bed set exhibit a range of dips from 4 degrees to 33, the latter likely being the original angle of repose of dry sand. The trace fossil association includes arthropod trackways that record the uphill, downhill, crest parallel, and switchback style movements in dry or damp sand. Some of the organisms responsible for these trace fossils were presumably aquatic, suggesting that the dune toe sets were at least occasionally submerged underwater. Others indicate subaerial environments, suggesting that the arthropods colonized these coastal dune fields as early as 510 million years ago. Many bed tops have straight or crescent-shaped sets of en-echelon microfault sets. These lamination-bound ripple-like features were formed by syndepositional tilting and slipping downslope. Fractures occur on steeply dipping foresets and can span several laminae. Some microfault sets bisect arthropod trackways. These microfaults predate lithification and were likely formed as damp sand fractured, slumped, and slid down the steep foreset dune faces. The Eolian origin of the Potsdam Sandstone in Hannibal Falls is suggested by several meter thick, steep, and laterally extensive crossbeds, low amplitude, and long straight crested ripples locally preserved on dune foresets, and textural and compositional maturity of the quartz arenite. A peculiar conical and vertical cylindrical structures within the cross-bedded and horizontally stratified Potsdam Sandstone were first described in the late 1880s, and they still attract the attention of many geologists. Petrographically, the sandstone forming the cylinders and the similarly hued sandstone of the cross-bedded strata that they cross-cut are identical. The structures are clearly delimited from the enclosing strata, and the color banding within the structures has been reported as subparallel to the contacts. Several mechanisms have been proposed as responsible for their origin. Probably the most popular one is the dissolution collapse of the underlying Grenville series marbles and the downward movement of the sand. Alternatively, the cylinders may be the product of remobilization of the buried sand accumulations by earthquake-induced liquefaction.